Good afternoon. Welcome to Johnson Space Center and to the post-flight briefing by the U.S. Microgravity Laboratory crew. Now I'd like to turn over the program to Commander Dick Richards. Dick?
Well, good afternoon. It's a pleasure to be back. It's easy to come back from flights like these that are so successful. Now the only hard part really is to try to convince everybody how successful we actually were. It was a great flight. All the equipment worked well. All the pre-flight planning that we'd done for over a year really paid off. And we've got a few slides and a movie to show you a little bit about what we saw and what we did on orbit. But before I get into that, I'd like to reintroduce my flight crew, who I'm very proud of for their just outstanding performance during our 2 weeks on orbit. To my right, Lieutenant Commander Ken Bowersox. He was absolutely essential during our flight. If we had a vote here for most valuable player for STS 50, Ken would probably be voted that. He was everywhere during our 2 weeks. Anytime any of us needed assistance, we couldn't find something, he was the man that was there. He knew where everything was, and I began to wonder if he had somehow snuck another flight in prior to STS 50, because he sure showed that space flight and he were easily accommodated. To Ken's right, Dr. Ellen Baker, who was our physician on board. She was also the one that let me get to sleep every night, because she ran the orbiter systems while Ken and I were asleep. She was also the one to make sure that we were keeping ourselves in good physical condition, made sure we drank all of our fluids, did all the things necessary so that we wouldn't spoil our 2 week stay in space by having problems during reentry, of which none of us did. And I was very glad to have Ellen on board the flight. To Ellen's right, Dr. Bonnie Dunbar, payload commander for USML, and she was the one that really pulled this flight together from start to finish, did all the interface with the principal investigators of the Marshall Space Flight Center, did all the work coordinating the flight plan with Marshall, and was just absolutely essential and instrumental for the success of USML. To her right, Colonel Carl Meade. Carl was mission specialist number 3. He was our astronaut on the blue shift and complimented the work that Bonnie did on the red shift. Again, just a fantastic job by Carl and making sure to keep us going in the right place. Anytime we got off the straight and narrow, Carl was there to remind us what the big picture was and make sure that we were doing the right thing. To Carl's right is Dr. Larry DeLucas, who many of you have seen at the University of Alabama at Birmingham. His first flight, but Larry, as well as the other payload specialist, Dr. Gene Trin, absolutely adapted to space flight most readily. The only thing we were sorry about for Larry was that we couldn't keep him up on orbit another week, which he expressed many, many times during the flight, that he wanted to just stay up on orbit a little bit longer and he could get all this work that he was doing with protein crystal work completed. And finally, to Larry's right is Dr. Gene Trin out of the Jet Propulsion Laboratory. Again, Gene became famous as the wizard of the drop physics module, of which you saw many, many hours of television with his expertise in manipulating these very difficult water droplets in a zero gravity environment. And he's got lots of words to tell you about how well drop physics module performed. And now I think I'd like to just quickly go through a 15-minute movie. Well, here's the NASA meatball, which now is a permanent fixture of all spaceflight movies now. And a good picture of our flag there and Space Shuttle Columbia's flag pre-launch. As you see, a few clouds in the area, but we managed to hold them off until long enough for us to get off the ground. Standard picture of us going out to the vehicle. It was kind of odd to be up at that time of the day. It was pretty easy for us, but Carl Meade, Gene Trin, and Ellen Baker had to sleep shift almost 12 hours, and they had just, at that point, they were about ready to go to bed, even though we were just getting up. Ken, you want to describe the launch?
Well, the launch was quite a ride for me. When the engines lit, I didn't get too excited, but I did look over to the left to see what the gantry looked like, and I noticed that it started glowing before we started moving as we got the reflections of the engines and the SRBs. Then it slowly moved out of the way. The liftoff sensation felt just like we get in a simulator. I was very pleased with the training that we'd had and felt very comfortable during the launch. I know the biggest impression I get on any launch is the bright lights. You can see a little bit of that here during the roll program maneuver. And unfortunately for our guests down at the Cape, we we disappeared into the clouds pretty soon after liftoff, so they didn't get to see us all the way out to MECO. But I can assure you the ride was very comfortable and very smooth, and the engines and SRBs worked just as advertised. Once we got up on orbit, we caught our breath and then started right to work activating the Space Lab. I was a little bit captivated by the scenery, but Bonnie was an old veteran and went right to work.
Well, the activation started out on the flight deck about 2 hours after launch by activating the Space Lab systems through the orbiter's computers. And then about 3.5 hours after launch, we went down the tunnel and I opened the hatch to the lab, ingress down through the tunnel and up over what we call the lip into the lab. We started operations immediately that day, and what you're seeing here is actually into the flight, and then here's some blue shift shots with Gene and Carl.
This is myself on the foreground working on the surface tension driven experiment, and Carl moving by holding a drop physics module film magazine, which he became so good at changing the film. This is a close-up of the drop physics module with the bay 1 door open. You can see some of the instrumentation inside. And this is a live shot, almost live shot of a drop deployment. And this is a very successful deployment. And thank you, Carl, for taking a picture of that. The drop physics module was controlled through the IVA that you see. That's a second CRT on the right. And this is a short sequence of the behavior of the drop in microgravity. These drops, once they were deployed, almost took a life by themselves because of their behavior in the absence of gravity, and also because of what we did to them with acoustic radiation pressure. The aim here was to determine in very quantitative fashion the behavior of those drops in microgravity. And this is another close-up view of the surface tension-driven convection experiment with the sequence of what you could see looking at one of the video downlink, looking at flow visualization pattern. These are speckle patterns of the tracer particles in the flow.
And this is myself working in the glove box once again, and I was doing protein crystal growth experiments, and here you see a close-up of the way I did that. I used common syringes, Hamilton syringes that you use in your laboratory. I basically did what I do in my own laboratory, which is what I've said for a long time we really need in space, is to have our own lab up there. And for the first time on USML, we had the equipment to do that and the time. And I was using a microscope to observe crystals that I grew on orbit, and from that information, looking at the crystals, I then decided how to change the conditions to optimize the crystal growth. And that's also the first time we've ever been able to do this in flight. And here's a crystal of the first protein that I crystallized in orbit. It's canaverin, and it's a plant protein that was donated to us by a professor at the University of California, Riverside, and canaverin's being looked at to genetically engineer a more nutritious food.
And this is the generic bioprocessing apparatus. And once again, these are the samples being loaded into a device which will measure the turbidity of each sample so that we can get essentially a time history of their development throughout the microgravity experience.
I think it's worth pointing out that for 13 days and 26 shifts, we had almost flawless performance of all of our hardware. And in fact, we were able to process more than we expected. I'm working in here in what's called a flexible glove box facility for the crystal growth furnace, which allowed us to change out potentially toxic materials. And we had a chance to evaluate this because we wanted to process more materials. And I think it's a good demonstration for space station. We had spare samples which allowed us to do this and actually produced more than we expected.
This is another shot of the glove box, and I believe an experiment in here which is called, this is smoldering combustion. I had to observe this for a little bit. They take a piece of foam and see how it smolders in microgravity, again without the benefits of buoyancy, or the effects of buoyancy, I should say. And it's another combustion type of experiment in that module which is in there, and it's closed up so that the particles can burn and not affect the crew in any way. As you can see, there's a video camera hooked to the top for data collection.
Again, referring back to the earlier slide, Larry and I spent several days of our mission working and performing experiments with a lower body negative pressure device. We also were able to visualize the heart during this process with a nearly off-the-shelf medical instrument called the echocardiograph, and it was a Doppler echocardiograph, and that it would use sound waves to also measure the velocity of blood flow going through the heart. And we got quite a quantity of data from that particular experiment. We're going to go back down to the tunnel now into the middeck and give you a feel for going through a little bit of what our obstacle course was and see what middeck operations were. If you recall, the lab is aft in the payload bay, and there's a very long tunnel that connects it to the middeck. We use this area as a little bit of a storage area, and I'll turn it over to Ken to talk about that.
Well, this had to be one of my favorite things to do up in orbit, cruising back and forth through the tunnel. It was sort of like being Superman, flying over long distances. It was a little bit of an obstacle course too, but luckily everything was soft, so it didn't hurt too bad if you bumped into things. Here we're entering the middeck, and you can see how we've got things hanging on the lockers with Velcro. And you can also see how easy it is to float on up through the hatch into the flight deck. And you just saw Dick's leg where he was on duty there.
This was, I can't remember where this was, over Australia or maybe over the U.S. Again, I mentioned we were able to beam people up and beam people down if they had the right ham radio equipment, and just talk to this individual, and you can see the picture come on the screen through the ham radio operation. This, again, turned out to be a lot of fun for us to do, and I think Ellen and I tabbed up that we were talking to about 100 people a day for the period that we were up in space, and I think generated a lot of goodwill for the space program throughout the world.